this is the test of the K-board. Okay, and we have a procedure. And this time, we hope the video cassette recorder keeps recording. Apply power, so we're going to attach our red wire to the red terminal, our green wire to the green terminal. We're going to plug in the K-board to the test fixture. Regular engineering. Okay, we're going to connect the 3 amp strip to the block signal detector.
What is the location?
This is our little block. Okay. Clip multimeter between white, blue, and green wires. So that's on our test signal. So here's the white blue. So we're blocking that one too. And 1, 2, 3, 4 down. I'm going to check my multimeter. 1, 2, 3, 4 down. Okay, set 25 VCC to 0 with pot R270. Okay, so I'm going to turn power on. And I'm going to zero this. Okay, I have my light on right there. I'll zero this with pot R270. Okay. Okay, so now we're going to do the next step, so I'm going to shut power down. Insert Delrin plug with small hole with detector holes, so we'll remove this. We're going to put our Delrin plug, which looks like this. It's going to go into the detector holes. Okay. Adjust position of the lamp. This is the lab lamp for 10 volts. So to do that, we have to, of course, apply power. And we're going to move this, watching our voltmeter, and we get some enormous voltage there. So adjust it so we don't get some enormous voltage there. And we get 9.95 volts, not 6 volts. And we're going to check V00, and V00 is the violet one.
The violet one is 1/25 of the 25.
And we see 0.397, and you say it should be 0.4, and that's close.
Yeah,
you say 1%.
Well, if you have 10 volts, and the 25th of it is 0.4
volts.
Well, we didn't have a little less than 10 volts.
And
so
exactly
we
why we
have
have a little less here too.
So you could have a calculator and simply divide it. Maybe the word should be, well, you know, in the end, we should find a way of adjusting this properly. You know what we may want to have is a little lamp that we slide over with a filter or something.
So if I get that at 4 volts, and I move one down, so now I should be a little bit higher than 10. Which I am, 10.26. So we're just looking for the ratio.
Yes, you look at the ratio should be 25.
Okay, but this one is just a regular.
You write things down, you see on paper, and then you take a calculator and check it.
I always find it Pyrex or quartz.
Okay.
It's recording, yeah.
Yeah, it's recording. Okay, now, insert Delrin plug. We did that. Okay. I'm going to shut power down. Couple laser radiation, which is emitted here, by fiber cable to the detector holder. So I'll take this out, give it a back. I'm going to use a, this one we're going to use a combination of fixtures. We're going to use the larger one here. We'll use this one. There was a smaller one too that I want to use as well. Okay. So that has this one and this one.
How much is it? 10 seconds?
Okay, my power is off. I'm going to put that on. Use my fiber cable. And I've already inserted the the larger opening here, which we use for now. This detector is still blocked. Apply trigger pulses to pin 2. Okay, now first we'll connect our scopes. Connect scope probe number 1 to green. Okay.
You should really change this. It should say connect trigger with the trigger signal.
Trigger signal, I think, is BNC cable between trigger outputs, so we'll connect that right here.
Oh, apply trigger pulses. What we do is switch.
The laser trigger on.
Yes, laser trigger on.
And we're going to connect the first probe to this white wire over here. This is probe number 1.
You don't need any of it. Just switch it on. That's it.
We're going to connect our second probe. We already connected BNC. We'll connect our second probe times 1 to pin 9 of IC202, which is reference number 1, which is very easy on our drawing.
Good news here. Now, go
Set
to
the scope to trigger mode
this
to display both scope channels, which we have already done.
I should just see observe both channels.
Yeah.
reverse it.
Put multimeter between yellow and green wires in J1, and yellow is 1, 2, 3, 4, 5.
Observe.
Down. 1, 2, 3, 4, 5.
No, the only thing I'm interested in, Mike,
Afterwards, I will
that's all right.
Okay. Adjust fiber
The
optic
calculation
cable
of the 50 wavelengths is serious, right?
until laser pulse height is approximately equal to 2 volts. So to do that, we have to, of course, first turn on.
temperatures if you read right out of the probe. How about that test would be okay? Okay, let's do it right now before you
It's okay.
let's do that.
And
Yes,
with the pulse right now,
now,
I want to go to 2 volts. I'm on a 1 volt scale, so I have to go up.
because this tool test by itself, Mike, is going to feature something.
And that's
I'm
approximately
going to go
equal
to
to
all
2 volts.
145 and see
Okay.
what was there.
And my multimeter should be reading 7 to 8 volts. I'm reading more 6.8 volts.
What was
So
it?
you're not exactly
Sensor
on
factor
380,
is
you know, it's like,
So that's acceptable.
yeah, I think that's, yes.
Record data, which we did.
Right.
Okay. So I'm going to turn this off.
Good. Next thing is tracking.
So scope channel 1
But we didn't hesitate to shoot it.
to 5 volts per division. Scope number 2 to 1 volt per division. Scope probe number 1 between yellow and green wires. So I have my multimeter on there, so I can take that.
No, not that. That's not scope. That's scope number 2.
Oh, I'm sorry, you're right. Scope probe number was this one. I think it was a white wire.
7.9.
So we make the switch there.
This would be, as you said, this one less.
Scope probe number 2 to pin 14 IC203. And that's reference number 3. 2 up on the, what is that? Reference number 3. That's over here.
What in this?
I don't want to embarrass myself or embarrass them.
Remove optical fiber from
Right now,
laser.
that's the filter. It's number one issue with leakage.
Okay, optical fiber from laser.
Sure establishes it, you know, zero.
I'll take this off, or that stays on.
Yeah, you have to take it off.
Multiply power. Okay, now I'll superimpose these so they match to 0. Okay. And I have 0. Well, I have 0.
That doesn't
Doesn't
matter.
matter. That's B0. So I'm going to insert the fiber optic.
Pause on it. No, it's probably not.
Right. Did I want to take those off now?
No, wait. We have to just get saturation, that's all.
So we'll see when it's saturated. So they are going up.
It doesn't quite saturate.
Doesn't quite saturate. So I'll take this.
We have to consider that when we design the tool.
Okay, Mike.
You need to saturate in one case and not saturate in the other.
Okay, you're gonna
I think about that
have
now.
to be in hand with the way that you want it
Let's
to
not
be
machine
done.
something so quick, I don't think about that.
We're going to cause first check over voltage.
I'm going to decrease the size of that.
No.
Let me just check. There's 0. I'm going to start to increase is
What you
this?
do, when you press this one on, say 1001, 1002,
Way up
then
Way up
your
there.
hand already on this
Let me
one.
see if I can get this
Also,
way.
turn on.
Then,
Way up there, yeah. There
6
they go.
seconds, right? And then you shut it down, and then you
One second, I should do this.
1001, 1002. On.
Just to see a little bit better, I'll take this one.
Yeah.
Now you have to reset these. I'll use the mark ones. Okay, now power on. Take this out. There's my 0 level.
Okay? Your hand on the, what's the voltage? Let me check it later on.
Now I'm going to start to decrease.
Because if I check it,
Go up.
okay.
So what you say?
Start locking.
Hit it.
Watch it 2 seconds.
There we go. Saturate.
Separate this, okay.
And then separate. Okay, that looks good. Power down.
Yeah?
6,
Up.
7, 8. Okay, we checked that okay
Yeah,
on
that's
that.
okay on that column.
And
Stop.
and actually I left out a step because
You got the
I
feeling
wanted
right
to
now?
keep my meter check.
You put it on, get it very
No,
small.
we did
No,
right.
14.5 volts. Oh, we can read that on the scope as well.
no, no,
Yeah.
6 months.
Or I could have just kept it.
No, you
hooked
could
up there.
you could that, but you know you see when it stops. You look at the scope. It's roughly just a little.
It's around
bit
50. Yeah.
6.
So if I do it this way, finally get it to saturate.
Correct.
Of course, this falling off.
That's not good.
There we go. We got 14 and a half volts. That with the city center. Okay. Couple laser radiation via optical cable from laser to reference detector DT200, which is this one. So I'll remove this very carefully. Put this in here.
See a mistake here. She said the 220. Yeah, it should be.
So I'll put the coupler on here.
I need maximum energy.
So for maximum energy, I'll remove all my spacers. And I'll also, just for the
Block.
heck of it, block this
Block.
block.
This is good block.
I can answer your question.
Okay, we're blocked over there now. Clip scope probe number 1 across R266. So scope probe number 1 is this one.
And I have a son of this. I told him
None of those
just come a little
numbers
off the ball. I think
change. This
it makes
is
it
valid in
so
the new
close.
new
That's
spreadsheet.
what I teach her when she works days during the day.
And this one coming point 03.
Clip multimeter between black and green wires. Black
Yes.
is 1, 2, 6 down.
We were the one actually alarmed them
5 down.
6 then?
that sets a factor was
6.
not reached.
And probe number 2, the pin 10, which is your second reference on here, which is this guy here, which is done.
Gotta get the right scale up here.
And I want to go, the scaling should be 5 volts and 1 volt or 0.5 volts on that side.
Right.
And I'm going to put power on.
Good.
And I see.
Glad to see that.
No, and I have my scaling mixed up. Okay. And so channel 1 is the 0.5 or 1 volt, and channel 2 is 5 volts. And what I'm looking at is this signal
Right.
over here. And I can
Right.
separate them if I wanted to.
Right.
Of course, to match the drawing, they look like this. And that's what I'm
This will be the special.
basically getting at this stage. That's it. Need a better scope.
Oh,
Just
0.5,
hit the
so
number.
that's okay.
Okay, and then we measure VDD. There's 0.5 there.
Same there, and you put that in there.
Same there.
Of course, there.
Okay.
Everything you
Well, you work that a little bit.
Everything you make, you
know
make
where
it
it's
here.
supposed to be.
Measure
Yeah, those
VDD.
papers.
Right.
Oh, that one. Those are not.
I should have 5 volts. I
One
put it.
from there. It's
And that
one.
concludes the test.
Right.
So I'll power down right now.
Right.
151 page.
150 yeah.
Has mounted to it a small gear which is pinned with spring pins, the hole drilled through the axis of the pot and through the hub of the gear. and this little gear carries the movement of the lens into the output of the potentiometer. The position of the lens is linearly related to the output voltage or the resistance of this part. It's 5 volt going in here in the middle, ground on one side, and output is the orange one, which goes eventually into the harness that goes to the A to D converter on the digital board. Alright, now the way this is mounted is you turn the front lens all the way in, which means you turn this, as seen from the front, all the way counterclockwise. Then you turn the pot all the way down to 0 or to the lowest value by turning it all the way clockwise. Let's just check, make sure that she put the right resistances in. It's done so that the computer never sees 0. It sees a little bit of a voltage, because the computer cannot distinguish between a low signal. I mean, if you let it come to 0, it could be something wrong. So it wants to see just a little bit of a signal. Now let me measure the resistance here. It should be 51 ohms. 51 ohms, yeah. Okay. So we know she wired the right resistance. Okay, now this fully clockwise, this fully counterclockwise, and we got to put a little what is this thing again? This Loctite into the lock that into the ball. Okay. Right, now if this is done right, we should see the same 51 ohm when we check it. Alright, put it in. Big gear, small gear to the big gear. And then before you sock it down, check the impedance.
I'm sorry, one whole time.
You hook up the ohmmeter between green and orange. Orange being the output, green being ground. Alright, it's all the way to the left, it's 51. You know, that's exactly what the value was. Now, if we turn the front mechanism all the way clockwise, that moves the lens as far forward as possible, we see something like 3.2, 3.3 kilo ohms. That's the correct value, right? That should be somewhere written in the description.
And you have grease on those gears?
Grease on the gears, yeah. I put it actually on a small gear, everywhere on a small gear. That will get it on the big gear. Right? If the small gear, if you put it on a big gear, you hit one spot.
Yeah.
If you put it on the small gear, it's a smaller area. It has to distribute over the whole thing. Okay, now that's done. Oh, see, it's okay. I showed it, but this is the anode. The cathode is this here. The anode is ground.
Which one else?
Near the
Where the flag is on the silicon detector. Where the flag is is the that little tag. Yeah, not the flag. Little tag. That's the positive one. That's the ground. See, I'm getting this off by putting this little knife behind.
Do you want some solder wick?
No, it's okay. I'll just take it off. Well, actually, we could use solder wick. Oh, yes, we got these things underneath here. The nylon washers.
We to glue this.
And you notice that I clipped them here because for whatever reason this hole ended up always way over here on the side. Sometime in the history of this thing it was in the middle, but somehow something's changed in the casting. In any case, just the way it's mounted.
What is the linear razor board or
What?
what board this is?
This is called This is the K board. That is the board, the analog board, K board.
We're going to
Right.
calibrate this one,
That was tested, everything done.
tested.
Yeah. Now we need numbers.
256.
256 is pan head, and 363
38.
is long. That's it. Okay, we'll put that away again. And of course, they need a little bit of that. Go back to this. What do we have? The shiny thing that wouldn't.
No, the plastic coated you need.
The paper is definitely not the right thing. You know what I noticed has to get these holes all over. See that the drawings have to be changed. But there's room to bring this over, to bring this over, to bring this over, so we have clearance here. I think at one point the casting was made thicker, and that ended up because
Yeah, the new they put the new so what's that
okay. Now, the purpose of this here is to get the where do I have the wire? The purpose is to get this on such a way that that this little tab is over this way. So, first of all, I spread this out a little bit so it's not. I make sure that this goes in between. All right, with the thing this way. Okay, so like this, come in like that. Okay. Okay. Now, it's also a little long. We want to clip it a little bit. Now, what we really should have around the hole. So when I look through, and we need 256 flatheads by
38.
no 1/2.
It's 5/8.
Yeah, and flatheads.
Flatheads.
Now, I'll tell you what I'll do usually to make life easier. Oh, I see. This one is. They make it a little shorter yet. Is interfering with one of the chips here. Okay, now, looking through here, we should be able to see this one. Okay. This here, why is this? Well, something is interfering here. Hold a minute. It's not inside. Let me pick them off. There's something is not right. Before was the rocking because there was a set screw here. See, once we glue these things in place, we don't need the set screws. The set screws are sticking out and interfering with the DC to DC converter. Okay, now we have this thing, and we don't want anything around here obstructing our access here. That's why I took this off. Okay. Now we have to see these two. I will just move the thing so that you can see it. Oops. Down here are the two pins of the reference detector, and I'm bending now these two wires down there to lean against those detectors.
Touching each other.
Touching. And I go in there with the soldering iron. I don't need any extra solder because the solder is still there from last time. Except this one doesn't want to. Gotta do something here. I need some solder to go in there. Can you hold that up a little bit for me? So, okay. I'll let this at an angle. Good. So you may need somebody to give you a hand on.
Oh, you saw that enough. The reason we put this
Started.
Okay.
You pull off the pieces of tape, and now you can take this thing out. All right, take it apart again.
Hi, Jamie.
How it's supposed to be.
Right here, Mara.
Wrench, there's nothing because
Completely where it should be. I want to bring this in. See, it's loose actually.
So you're adding more solder?
Yeah. On one side only. While the other one is there, right? I move this over. Okay, this is good. This is the other one. The other side was fine. Business card. Anybody has a business card. See, this one now has to be shaved.
And what that's going in
I'll show you
where?
what it is. It goes underneath here. Have to just, I give it a slight little cut like a, okay, and down here it has to clear that cap there. This is like a tailor here.
This is the glue.
Yeah, we have to glue this, okay? I just want to get it going. This is good enough. This is okay. Okay, now pushes it up. And pull it through. See, this way you have something underneath to push it up. Now we need some 5-minute epoxy.
Put the paper in and you folded it.
I folded it and pulled it through so to put like a push up this thing.
Like a spring.
Yeah, like a spring. Okay, so that it pushes up.
Why you put the paper up there?
Well, so that it pushes this. Oh, you'll see in a minute because it gives it some support so it doesn't flop around the breeze. These boards don't go in the same way each time. You see that already, right? So they go in a little different each time. So you can't really put this thing in a fixed position. Well, then we look for a connector and so forth. But you have short pulses. You can't fool around too much here. No.
Oh, now you hold this thing with the glue over there.
Do like little like this, yeah. Okay. Okay. Bene. We don't touch anymore. That's good enough. Useful to do.
You're putting shrink tubing in?
String tubing on there, yeah. Now this, in the future, you know, Ida says she doesn't have enough shrimp tubing, so she didn't, you know, normally she does that. This will take a little effort for me to get her, you know, to straighten it all out so she has all the documentation and all the parts and everything. I want to talk to her today because I'm concerned not hearing from her and not getting the mail. She's supposed to send me something.
Starboard, right?
That's the laser pulsar.
Also.
Right. Okay. All right. That's good. All right.
So you crazy glue them right there?
Yeah. Make sure it goes over the end where the screw goes. at the top and the bottom, you know those. Good. Put this down. Right. And now we need some. Again, we need number 2.
6 by
Yeah, these are the ones we use to mount the boards into the.
3/16.
Right, by 360. All right. You never sock it down. You know, you know why, right? You let this.
Oh,
A
why
little
this hole
play,
is
little
bigger?
play. Well, yeah.
The reason it
That's
is
why
bigger
it
because of
works.
play.
Yeah, I still have to. You have to grind, but you let the.
More room for.
Well, you don't want to sock down one screw before the other one is engaged. You know, you want to need a little flexibility. All right. Here we go. This is the one. This here. This here. It should be okay. Okay. I'm like one of these tough peasants, you know. But he looks.
Before him, the guy live only 1 month, right?
Is
Yeah.
it before him? Yeah, you're
Only
right.
1 month.
He just died. It's something right. That's it. Okay.
So you clean that detector?
Yeah, I cleaned it because I touched it. You know, it was the red one goes into here. That's the power. The white one is the trigger wire. This goes it through, and I bend it a little bit to get out of the way. And this is a ground pin here. Now, these other 2 are superfluous. They're from some previous. They're in there for some other design. Is that off? No. You can get rid of this one.
And what are you soldering those into the cups?
Say again.
Yes.
No, I have never done that. I've never done that. I leave it because I want to macro. I never had a problem with that, by the way.
Okay.
These are good pins. I mean, I think they're machine pins rather than stamped, so they're pretty decent. Now I need the stuff, not asked to. I just want to get rid of this word bad here.
What's
That
that?
wasn't bad. That was my assistant. He just wrote down bad because he tested it and it didn't work right. Now, this detector is the signal is amplified by this LF355. Okay, it's just amplified. Then it's and then later it is goes to a sample and hold. But before it is amplified, after it's amplified, this is basically a sort of an integrating amplifier. It has an RC, has a resistor and a parallel capacitor in a feedback loop. That we call an integrating amplifier. Now, what you are, in order to get the signal strength adjusted to it, because the signal varies a lot here, simply the way that laser's coupled in, you know, when you don't have the beam exactly in the middle, it's different, you may catch an edge. So you adjust the gain of this amplifier by changing the capacitor. Also, she's been putting in 27K, we want to go to a higher number. I just want to make sure systematically, this will. So we leave. This is fine. This is correct. This somehow, either I corrected her or I did it. I've forgotten now. She may have the right number already.
270K.
270K.
Okay.
This will be always like that or change?
They're the same. They should always be the same.
And the capacitor changes.
The cap.
Only cap is changed according to the gain.
Yes, right. You adjust the gain with different caps. Is glue in this thing here. Okay, this way.
Stanley, before you do, we have a red wire connected with this pin, and the white wire.
This is the ground. This is a ground pin.
Yeah.
The white one goes in here. That is the pulse. The pulse signal. This is the power supply. Okay?
Red one is power supply. Then the
to
pulse.
this board. The white one carries. Let's see if this already is bent. The white one carries the trigger pulse, which comes from the computer. This harness goes into the computer. The white one carries the trigger pulse into here, and then from there into this board.
Okay.
Okay, now we have done that. This is it. Okay, now we have to glue in this thing here. But I did it wrong. That to be glued in like this. Also, if you have insulating tape. What's it called? Kapton? I'll put it here. That's good. Now we need some 2-minute epoxy. Hey, this is great for mixing epoxy, by the way.
Yeah, right.
Okay. So in this corner here. Okay.
What's that going to connect out?
This is going to connect. It's going to be like this. It's going to connect all the ground leads from the battery and from the various boards go into there, into this terminal, and all the hot leads go essentially from the battery is one. It's basically hooked up to battery plus. Okay, this is the battery plus. This is the battery minus. All the ground leads go to battery minus, and the other one go to battery plus. Tech has all the secondary pins that correspond to the switch function soldered together. The power from the battery lead is white and goes to the wiper point. Where is this? Here. Evidently, this should be. Let me do this the right way, and then pot, the wire one pot.
So you put them in after the reference detector is soldered.
After the reference detector is soldered, because you need the clear access to to these wires here. Okay. Fully clockwise, fully counterclockwise. There's a piece of paper underneath I had here, which I have to put back. It just got caught. Yeah, and so I put in the spacer to ease up on the fit between the two gears. They don't have to be engaged, strongly. They're just, as long as one, there's no force on this. So they don't have to be, and a little bit of backlash is not going to be a problem. So these gears, and it's not a critical, oops, there we got it, okay. So let this off. And we, this in. I want to put some Glipton on this one, although really put Glipton on that one. It should be on there too. Yeah. Put Glipton on when you want to. You don't want to commit yourself. There you go. Okay, it should fit in very nicely. nicely here. See, the detector fits right up, but there's something is hanging it up here.
Capacitor?
This capacitor and this capacitor here, and this transistor have to be bent forward, and this one forward, and bend this one here this way. This one this way, this one that way, to stop interference. Now I put this in here. You don't have a dentist mirror, but you would see that it fits in snugly, just exactly right. And now, put those two things in again. You know, I had a drive it all the way home, you know, you want a little standard way. And you have to connect this cable to that cable. This red to red. See, red to red. The other, you know, see the other colors line up. Underneath here, took this one underneath there. Then we are hooking up the laser. Make a right angle turn here. Put a little without having the things fall in. Then we have the red. This red one goes to the make sure that this is connected right. Should be. Center conductor is negative, yes. Okay. Be connected now to this here. The green one to the green one, and the orange one to the orange one in the middle. So orange, orange, white, red, green, green. Okay, now that we tuck underneath here, out of the way. I want to have this harness a little bit different, a little shorter, I think, next time. Anyway, this is down here. These things are connected. Alright, so now this one should go into the fixture.